I have been afraid to make this story. The story of history's most famous radiological accident. I've been avoiding it for years because I knew just how much time and effort it was going to take to tell this story correctly and accurately. But after reading through 546 pages of material and taking 28 pages of notes, I am not afraid of this story. I am furious about it. What you're about to hear is not the simple retelling of Hisashi Ouchi and the Tokaimura Criticality accident. You can find that anywhere. No, this is the real story of how history's last criticality accident became nuclear misinformation.
The accident occurred here at the 3 Mile Island nuclear power plant.
Japan is a beautiful country, full of history, brimming with culture, and populated by a hard-working, industrious people, perhaps to a fault. If Japan lacks anything, geopolitically speaking, it's energy. Unlike energy-rich countries like the United States or Russia, the island is relatively bare and has to import around 90% of its energy from other countries. It's not surprising, then, that despite Japan's complicated history with the splitting of atoms, it is one of the world's top nuclear energy producers. Nuclear in Japan is a solid source of energy security, whose share has fluctuated, before Fukushima, between 20 and 30%. Japan has long sought to take this security one step further by implementing what is called a closed nuclear fuel cycle. Instead of disposing of spent fuel in interim dry cask storage or deep geological repositories, it's one of the very few countries with the capacity to close the loop, to reprocess spent fuel for further use via chemical and nuclear processing facilities. This infrastructure remains today, despite history's most famous criticality accident happening at one of these very facilities. Japan, September 30th, 1999. Tokaimura, a large village 120 kilometers northeast of Tokyo. The JCO uranium conversion facility. Inside one of 3 conversion buildings at JCO, 3 men were preparing to purify a solution of enriched uranium, using chemicals, agitation, and precipitation to do so. The fuel that goes into most nuclear reactors contains around 3 to 5% fissile uranium-235. On this day, the men were handling an 18.8% solution for an experimental reactor, a concentration with enough nuclear material that it necessitates multiple steps to ensure that the liquid can never be arranged into a state where a self-sustaining nuclear reaction, criticality, can be achieved. JCO facility technicians Hisashi Ouchi, Masato Shinohara, and Yutaka Yokokawa were rushing to finish a special batch of fuel. Ouchi, usually denoted as Worker A in the many reports that would follow, had never been in this building before. He and his colleagues were pressured to hurry out fuel via a new procedure for the experimental Joyo fast reactor. But it was the first time either Ouchi or Shinohara were following this new process. It should save a lot of time. Instead of dissolving uranium in a large tank, moving it through multiple specially shaped columns, and having those columns slowly dole out the mixture to a precipitation tank where the purified uranium could fall out and be separated, the most recently approved procedure was now to mix significantly enriched uranium liquid in a simple stainless steel bucket and pour it directly into the tank. The day before, on September 29th, workers had already poured 4 batches of liquid into the tank this way. The steel bucket and the direct pour method worked fine. The batches that Ouchi and Shinohara were now adding to the tank were 2.5 kilograms of uranium solution each. However, this was not the limit for batches. This was the mass limit for the entire tank, and on September 30th, it was already 300% over that limit. But Ouchi and his colleagues didn't know that. Workload was high. Financial pressure was on. None of the workers that day were thinking about the dangers of pouring so much nearly weapons-usable uranium into a single vessel because no one had explained to them what criticality safety even was. Why? because the operator and regulator believed that a criticality accident was impossible at this type of facility, and in Japan, periodic inspection during operations seemed not to be a legal requirement. And then, this Titanic hit the iceberg. At 10:35 a.m., Masato Shinohara was standing above the precipitation tank with a 7th bucket of enriched uranium solution, which would bring the total in the tank to 16 kilograms instead of 2. Hisashi Ouchi was standing with the funnel, and Yutaka Yokokawa was sitting at a desk 4 meters away. This short distance would end up saving his life. The moment the 7th bucket was poured, the men reported blue-white flashes, a shockwave, and sounds they had never heard before. Radiation alarms on the ceiling were blaring.
"Run for your lives!"
Yokokawa shouted. Within just minutes of escaping to the nearby changing room, Hisashi vomited and lost consciousness. In nuclear science, criticality is the term for when the number of neutrons produced by the splitting of atoms, fission, equals or exceeds the number of neutrons lost in some material or machine. In each case, the reaction is self-sustaining, but the conditions matter. In a nuclear reactor, criticality is basically 1. For each fission event, there is on average an additional fission event. This is a controlled release of energy. In a nuclear bomb, criticality is much higher than 1, and this exponential increase in fissions releases the power of the atom almost instantaneously. That's how a butterfly's weight of mass converted directly into energy killed 140,000 people in Hiroshima. The first critical reaction assembled by humans happened in a squash court underneath the stands of Stagg Field at the University of Chicago on December 2, 1942. The first critical arrangement of uranium on Earth that we know of, however, happened at least 2 billion years ago in the Oklo deposit in Gabon, West Africa. But if nuclear power and weapons is all about ensuring criticality, actually working with and handling nuclear material is all about preventing it. There are 9 different ways to control criticality. 1. Through mass and volume. More neutrons escape from smaller amounts of material. 2. Enrichment. The more fissile isotopes you have, the less of it you can safely bring together. 3. Geometry and shape. If a sphere is the best way to put the most material between 2 points in every direction, using shapes that promote neutron leakage is safer. 4. Interaction and separation. Neutrons are highly penetrating, so you have to think about not just one fissile object, but any fissile objects nearby. 5. Moderation. Like needing a certain velocity to best sink a golf putt without skipping over the hole, certain materials in the presence of fissile ones can make a chain reaction more likely to happen by slowing neutrons down. Because they contain water, even human bodies are good at this. 6. Reflection. If too many neutrons are leaking from a volume to make it critical, reflecting those neutrons back into the volume can make up the difference. It's the reflector that caused history's first criticality accident at Los Alamos in 1945. 7. Concentration and density. Closely related to mass, volume, and enrichment, the higher the density of fissionable atoms in some solid or liquid, the more likely it is to go critical. 8. Neutron poisons. You can have a critical assembly under control if you artificially decrease the number of neutrons available in a volume. This is what neutron-absorbing materials in reactor control rods are for. Finally, 9. Heterogeneity. A safe mixture of material can be made unsafe if how it is spread out has changed. This is how Cecil Kelly died, after a liquid mixture of plutonium was spun up by a machine. In the nuclear industry, there are many practical applications of all these interrelated factors. In this figure here, for example, you see containers on a wall with safe geometry, spaced apart, next to a passing technician who has a safe boundary line he is following, and his own container fitted into a cart that specifically prevents it from being both loaded with more material and placed too close to other containers. There are many, many more ways criticality can be safely controlled. That is, when the all-too-human desire to make things as quick and as easy as possible doesn't override them. What went wrong when Masato Shinohara dumped the 7th bucket of uranium into the JCO precipitation tank? He broke the mass limit with a highly enriched material in liquid form, in a tank with unfavorable geometry and a water jacket around it that absorbed heat but also reflected neutrons. All of this acted to greatly reduce the effective critical mass of the uranium mixture, such that the instant these failures came together, While Ouchi, Shinohara, and Yokokawa were being rushed to a hospital in Chiba, authorities were rushing in to control the situation. They were quickly stopped by radiation rates 8,000 times higher than background. And even 6 hours after criticality occurred, the neutron dose rate was higher than that, meaning that not only did something go critical, it was still critical, oscillating over time as liquid reacted, released energy, and rearranged itself in the precipitation tank. And the fact that neutrons were being released was a problem bigger than the building. Electrically neutral and relatively massive, neutrons are both the most penetrative and most damaging of all radiation. So 4.5 hours after the accident started, authorities started evacuating residents within 350 meters of the plant. Thanks to the inverse square law, this was more than enough. But this was also Japan's first criticality accident, so authorities overreacted. 12 hours into the accident, the evacuations and warnings were expanded. 310,000 people were ordered to remain indoors. Schools were closed, roads were blocked, and trains were stopped. The governor of the prefecture didn't know what kind of danger he was dealing with, and so he also told residents to avoid hospitals and suspended the harvesting of crops. Neutrons don't contaminate the environment like a failed nuclear reactor does, and this confusion would have a similar, though much smaller, economic and mental health impact as Fukushima a decade later. Back at the facility, experts realized that the cooling water jacket around the precipitation tank was likely acting as a neutron reflector, and thus continuing criticality. So teams suited up and prepared to drain the water. At 2:30 a.m. the next morning, October 1st, success. To further decrease reactivity at around 6:30 a.m., they used a fire hose to pump boric acid, a neutron poison, into the tank. Just a few minutes later, dose rates were back below the detection limit. The governor lifted shelter-in-place advisories by that afternoon. Unfortunately, the situation was not over. Fission reactions create fission products like radioactive cesium and iodine, and neutrons can activate or make radioactive other materials. So the assembled task force placed shielding like concrete and sand all around the building and limited their personal exposure by limiting the amount of time they could work in the area. From beginning to end, the radiological incident at the uranium conversion building in Tokaimura lasted about 20 hours. But for Hisashi Ouchi, the disaster had just begun. The 35-year-old technician was about to go through 83 days of medical misery. And partly because this was the first time in history a radiation victim's struggle was being documented widely and publicly in real time, low-effort internet horror slop would eventually scrape up the details of Ouchi's story and contort it into dangerous misinformation. Normally, I don't get on camera for these kinds of videos. That's because it's not about me. It's about the history and the context and storytelling and education. But in this case, I felt compelled to speak to you directly because with this, I am just so disappointed. Like any good nuclear enthusiast, I was aware of Hisashi Ouchi and his death well before making this piece. It was always one of those not suitable for work oddities on the internet. And according to those oddities, what I'm supposed to say next is that Hisashi Ouchi was the most radioactive man in history, and that his doctors kept him alive against his will, and that his body basically disintegrated. Well, only that last part is true. Hisashi died after 83 days of intensive medical care, over which he lost all the white blood cells in his body and all the skin on the front of his body fell off. It's a gruesome way to go, which we've covered before, and I don't feel like we need to indulge in it here. Why I'm so disappointed in the modern understanding of Ouchi's story is that, first of all, he was not the most radioactive man in history. He died after encountering around 20 sieverts, while Robert Peabody, who we've also made a video on, died after encountering over 100. More importantly, though, Ouchi was not kept alive by his doctors against his will like some experiment in human suffering. And this narrative continues to warp people's ideas of medical care and professionals, in my opinion, to this day. Finally, almost all of the photos, almost all of them you see associated with Ouchi are either fake or not him. I know this because I read the book. This is the book A Slow Death. It was compiled from an award-winning NHK TV report on the accident. You can buy it right now, or you can read it for free using the link in the description. This is the primary source, 141 pages of direct reporting and first-hand accounts from the doctors and nurses who actually treated Ouchi. In my mind, if you're going to make any kind of art about this story and make money from doing so, you must read this book. Many videos on this platform have not done so. I know this because they craft an entire narrative around a single quote. After the first few days of invasive and painful treatment, Hisashi blurts out, "I am not a guinea pig!" Misleading videos like this one from the infographics show then take this one line and use it to inaccurately infer the intentions of Ouchi's physicians like this.
He begged the doctors to let him go. I can't take it anymore. I am not a guinea pig. Unfortunately, the doctors, partly thanks to Ouchi's own family wishes, didn't listen.
This happens in videos all over YouTube.
They make a controversial decision, though, and decide that whether Ouchi likes it or not, he is now going to serve as a guinea pig for treating radiation illness. This is, after all, a once-in-a-lifetime medical opportunity.
Either way, we're not sure which side of the story to believe. It's like the doctors found the lab rat, and they were doing all types of experiments.
He was kept alive against his will for 83 days and subjected to unimaginable agony.
It is my contention that this single line has forever twisted Ouchi's tale in the public consciousness. You might even buy the mad scientist narrative when you first hear it. However, that's only if you don't read, the rest of the book. Keep this medical horror story framing in mind as I read you some context from the primary source. Okay? So, the Criticality accident at JCO had been contained and Ouchi had entered medical care. Radiologically speaking, there wasn't much reason to try and prolong Ouchi's life, but in Japan's culture of honor, the physicians considered it their sworn duty to help Ouchi and his family until the very end. 83 days of fighting against a fatal dose of radiation does seem like a kind of torture, but keep in mind that the doctors and nurses were working in the dark on a case that no doctor in Japan had ever seen. No one had survived as high of a dose for as long as Ouchi did, and the doctors believed in the small chance this incredible resilience gave them. Ouchi's life, or what was left of it, was therefore not just medically significant, but internationally important. Accordingly, his doctors worked not as mad scientists, but as heroes, basically living in the hospital with Ouchi, spending hours and hours cleaning bandages just to make him look better for his family, renovating the waiting room just to make his wife, son, mother, and father more comfortable. During this time, everyone, doctors, nurses, technicians, international specialists, everyone thought about Ouchi's suffering. Everyone was questioning themselves. After his heart stopped 3 times in 1 hour, something that many bad YouTube videos will focus on, the family still believed in Ouchi, but not in continuing his life at any cost. The next time his heart stops, the lead doctor told the family, "I think it's best that we don't administer resuscitation." The family said, "We understand." When Ouchi finally passed, the medical team's physicians shed tears while accompanying his body to the morgue, and a small flower bouquet offered by the nurses was placed on top of the coffin. "I've learned to ask the doctor to change the treatment method so the patient won't suffer," one nurse said, contradicting the common narrative directly. "I feel more strongly about being on the patient's side." Ouchi's wife, with tears in her eyes, reportedly said, "Thank you for everything. You took such good care of him." If this doesn't sound like medical compassion in the face of impossible odds to you, it did to Ouchi's family. They saw him almost every day, listened to and approved every treatment plan, and despite Ouchi's deteriorating condition, they still had complete and total faith in his doctors and what they were doing for him, not to him.
大内さんを守るためにやってるんだって思わないと耐えられないケアばっかりでした。
As a member of the medical care team, I know I shouldn't talk about guilt. I still haven't come up with the answer. I want Mr. Ouchi to answer. I don't mind what the answer is, I just want him to reply. He can be angry at me and he can tell me that it was awful, that he suffered, I don't care if he doesn't thank me or if he really gets angry at me. I just want to have an answer from him. I cried when I first read that. When you have firsthand evidence like this, it is at the very least embarrassing when you don't include the proper context. And at most, it is shameful. You are dishonoring Ouchi, his family, his international care team of doctors, nurses, scientists, and specialists. Can you even imagine telling his head doctor that he treated Ouchi like a lab rat when after Ouchi's death, the lead doctor questioned even being a doctor anymore? Because he was so distraught. Not only is the most popular narrative objectively wrong, so too are most of the photos you see accompanying this story. The following contains extreme graphic imagery. Discretion is advised. It's shocking, but necessary. This is the horrific image most associated with Hisashi Ouchi. But this is not him. It's an image of a burn victim first published in the Burn Journal's Treatment of Extreme Full-Body Trauma, 4th edition, Total Burn Care, 3rd edition, and Principles of Burn Surgery. Just like Eben Byers, a random image got attached to the story and the internet did the rest. As one Redditor who did a deep dive on this ghastly photo concluded, quote, "Pretty much everything that has ever been written online about this photo for the 11 years that it has circulated has been complete bullshit." The second most famous of Ouchi is also objectively not him. These are the only verifiable photos of Ouchi before the accident. Very little exists of him afterwards except for what was in press photos and news reports. Here is a rare photo of Hisashi being escorted into the hospital. You can see that his right arm, the part of his body closest to the precipitation tank, is already bright red. There are more photos, but most of the best ones are, again, in the Slow Death book. This is the end of graphic images. If you're interested in this story, I do recommend reading this entire book. Again, it is free as a PDF down in the description. It's short, it's relatively well written for a translation, and it's clinically clear. It's clear, though, that many people haven't read this story when they want to make a story of their own about it. Too often now I've seen horror slop that leaves out context that can change the entire angle of a piece. The human element. When you have an amazing source of the human element at your disposal, you are compelled to include it. Only then might you start to understand how one man could endure so much pain, and how you can prevent his memory from experiencing more. In the end, it was determined that the criticality accident at Tokaimura resulted primarily from human error and serious breaches of safety principles. Safe geometry was completely bypassed by Ouchi, Shinohara, and Yokokawa. The change was proposed by the workers themselves to alleviate the pressures of producing a special batch of uranium fuel for an experimental reactor. And in this rush, the fatal change was made just the day before the accident. As the science of risk management points out, even what appears at first sight to be a simple equipment breakdown can usually be traced to some prior human failure. Human factors dominate. Thankfully, though what became a naked reactor in the Tokaimura conversion building emitted an estimated 500 quadrillion neutrons, no one outside of the building experienced any health effects. No radioactivity in the water or on the ground. This makes perfect sense when you know what neutrons are and what they can do. However, the public, by and large, does not know what neutrons are and what they can do, and so at Tokaimura, there was confusion and panic. Approximately 10,000 residents requested medical checkups, stressing the local healthcare system. Journalists in a helicopter took photos of a building damaged by a fire and published them as though they were the JCO facility. Much of the information was inaccurate. Neither JCO nor other local nuclear industries had websites to provide factual information. As a result of non-existent science communication, residents suffered from evacuation and misinformation-induced physical and mental health effects. Goods were returned. There were boycotts. Tourists canceled their visits to the prefecture. Unfortunately, it wouldn't be the last or even most costly, unnecessary evacuation of Japanese citizens. 3 months after the accident, the entire JCO plant was shut down and its operating license was revoked. The first plant operator in history to be punished under Japan's nuclear regulatory laws. The company president resigned in disgrace. By April of the following year, economic measures taken to calm this hysteria had cost over 12 billion yen. On October 11, 2000, Japan arrested 6 officials from the JCO plant and charged them with professional negligence. Among them was none other than Yutaka Yokokawa, Shinohara and Ouchi's supervisor, sitting at his desk that morning. Anti-nuclear activists seized on the accident to condemn Japan's commitment to nuclear energy. A poll indicated that 70% of the Japanese public now opposed nuclear power. Masato Shinohara had also died of multiple organ failure from acute radiation syndrome earlier that April. You may get a sense from these stories that accidents like this are happening all the time, but they are the exception, not the rule. What happened to Hisashi Ouchi and Masato Shinohara was actually just the 60th recorded criticality accident in the 58 years since Enrico Fermi first went critical beneath the University of Chicago. This is around 1 accident per year. I say just 1 accident per year because, as a comparison, in 2023 alone, a worker died every 99 minutes from a work-related injury in the United States. A report submitted to the IAEA years later would hope that Tokaimura would be the last fatal criticality accident in Japan, and there hasn't been another criticality accident in Japan in the ensuing 27 years, or anywhere else. Tokaimura was the world's last fatal criticality accident. While Ouchi's family waited for their daily briefings and visiting hours in the University of Tokyo hospital, they spent their time and anxiety folding paper cranes. By the time Hisashi died at 11:21 p.m. on December 21st, 1999, they had folded nearly 10,000 of them. A portion of the nearly 10,000 paper cranes folded by Ouchi's family was left in the hospital waiting room. Colored paper with soft, pale hues were carefully folded, one by one, stacked and secured by beads at the bottom. Head nurse Shihoko Kobayashi says, "These paper cranes are full of prayers. I can't bear to take them down." Still bearing the family's hope, the paper cranes continued to shine in the soft light that flooded through the lace curtain. Until next time.